Hello, everyone. Today, we're going to cover Chapter 4, Part D, and we're going to answer the following question. How accurate is our forecast? To measure forecast accuracy, we're going to use the following quantities: the mean squared error, MSE, the mean absolute deviation, MAD, the mean absolute percentage error, MAPE. They represent how large the errors are in the forecast. So the lower the values, the errors are, the values are, the better the forecasts are. Now, I want to take an example and show you how to compute these quantities. The following table shows the actual sales of upholstered chairs for a furniture manufacturer and the forecasts made for each of the last 4 months. Calculate the MSE, MAD, MAPE for this product. So the first thing you need to do is compute the forecast error. The forecast error is defined by the demand minus the forecast. So in the first month, the demand was 200, forecast was 225. Subtract the forecast, you get negative 25. That's the error. Second month, 240 minus 220 equals 20. The third month, 300 minus 285 equals 15. The fourth month, 270 minus 290 equals negative 20. Now we have 4 errors, and we want to have a single value that represents all the errors. So how can we compute the single value that represents 4 values? How about if we just average them? Now, what's wrong with averaging these numbers? If you average these numbers, these plus signs and negative signs will cancel out each other. But what does it tell us? Negative 25 means that the forecast is 25 away from the demand. And the forecast is 20 away from the demand, and 15 away from the demand, and 20 away from the demand. We don't care if the error is negative or not. We only care about how far away the forecast is from the actual demand. So in other words, we are interested in the absolute value of the error. We want to drop the sign of the error. So how can we drop the signs? There are a couple of ways to do this. The first one is compute the absolute value. And the second one is square the errors. If you square a number, you can drop the negative sign will disappear. So let's first square the errors. Okay, if you square the error, negative 25, you get 625. The negative sign is gone. If you square 220, you get 400. Again, the sign is positive. 15 squared, 225. Negative 20 squared, 400. Okay. So these are the squared errors. And now we can average them. If you average them, you get 412.5. This is called the mean squared error. Now there's another way to drop the sign. That is, compute the absolute error. So what's the absolute value of negative 25? 25. What's the absolute value of 20? 20. What's the absolute value of 15? 15. The absolute value of negative 20, 20. And let's compute the average of these 4 numbers. And that's going to be 20. And this is called mean absolute deviation. And the last quantity is the absolute error over demand times 100. What's the absolute error? 25 over demand. Demand is 200. The quantity times 100, you get 12.5%. And then you can repeat this for the rest of the months. Absolute error over demand 240 times 100 equals 8.3%. Next, absolute error over demand times 100, 5.0%. Absolute error over demand 270 times 100, 7.4%. Now we can compute the average of these percentages. That's 8.3%. That's the mean absolute percentage error. Okay. So now I want to make a couple of comments. First, I want to make a comment on the MAPE. When you compute the MAPE, we divided the error by the demand. Why do we do this? To illustrate this idea, I want to give you an example. Let's say we observe the demand and the error for the two periods. In the first period, the demand was 100 and the forecast error was 100. In the second period, demand was 1,000, the error was 100. So in both periods, the error was the same. But does this mean that this forecasting method worked equally well in each period because we have the same amount of error? No, in the first period, the error was the same as the demand. The error was 100% of the demand. But in the second period, the error was only 1/10 of the demand. It was only 10% of the demand. So it's more reasonable to say that the forecast in the second period was better than the forecast in the first period. So what's more reasonable is to look at the ratio of the error to the demand. So that's why we're using the MAPE, mean absolute percentage error. Now, in the second comment I want to make, I want to look at the mean squared error. What's the difference between the mean squared error and mean absolute deviation? In MAD, we use the absolute errors. In MSE, we're using squared errors. What happens if you square a number? If you square a number, you're making a large error much larger. For example, if you square a small number, say 2, 2 squared is 4. So this number has increased. The difference is 2, right? It increased by 2. But if you square a large number, say 10, 10 squared is 100. So it increased by 90. So if you square errors, you're making larger errors much, much larger. So you're emphasizing these large errors. So let's look at the following example. Suppose you have two forecasting methods and we want to compare them. The first method produced errors 60 and 60 in period 1 and period 2. And the second one produced errors of 1 and 100 in periods 1 and 2. Which one produces better forecasts? In the first method, we have moderate-sized errors. In the second method, we have one particularly large error. So when we compute MSE, MSE will emphasize this. It's going to make this much, much larger. So according to MSE, the second forecasting method will have a much larger error. So if you actually compute the MSE, the second method has much larger MSE than the first one. But if you compute MAD, the first one actually has a larger error. Okay? So we can see that MSE treats larger errors more seriously. So if you would rather have moderate sized errors throughout the periods, and you don't like to have one particularly large errors, you can choose your forecasting method according to MSE. This is everything we have for this part. I'll see you next time.